Hi folks, welcome back. So over the last couple of months, I've been building Proceda, which is an AI harness or SDK for turning standard operating procedures, SOPs, into runnable AI agents. And Proceda itself is open source. It's on GitHub. I'll leave a link below. Today, I am happy to share that Proceda has achieved state-of-the-art performance on SOP-Bench. And that's what I want to cover in this video. SOP-Bench is a benchmark created by Amazon Science that consists of more than 2,000 tasks across 14 different business domains. And the benchmark comes with mock data and mock tools, the SOPs themselves, of course, and also ground truth labels. What was the correct expected response of executing that SOP on a given set of inputs? So huge kudos to the folks at Amazon for putting out this benchmark. I think this is further recognition that automating SOPs is one of the most important, if not the most important, business use case for AI agents. Now, I did have to put an asterisk on this claim, and the reason for that is that I ran into some bugs in the benchmark itself in terms of some of the tools didn't quite work, and some of the ground truth labels contradicted the instructions in the SOP, in that if you followed the instructions correctly, you would get answers different from the ground truth. And in the spirit of improving the benchmark, which also, by the way, is open sourced and available on GitHub, I have filed a number of issues on the GitHub repo that has detailed description of the issue and what the expected behavior should be and so on. So I'm hoping these issues are helpful. But getting back to the benchmark and Proceda's performance itself, let me get straight to the results. So of the 10 business domains that I was able to execute, Proceda was able to get SOTA on all of them, and on some of them by as much as nearly 13 percentage points. That's one, but the other main headline finding is that Proceda was able to get this SOTA performance often with much smaller and cheaper models like Gemini 3 Flash and Gemini 2.5 Flash compared to the models that they used in their baseline performance in the SOP-Bench paper itself. So they had to use models like Claude 4 Sonnet or even Claude 4.1 Opus in order to get the baseline performance that they got in their paper. So here is a graph of that same SOTA result. As you can see, it is SOTA on pretty much everything. I want to quickly mention about this patient intake benchmark, which seems to be a bit below SOTA because it is 97% compared to 100%. And I would argue that it is actually 100% because the two failures are logically consistent with an interpretation of the SOP. So they run into an edge case where if the insurance is invalid, the LLM will skip checking the prescription benefit, but technically that doesn't quite match the ground truth labels. The other big headline is that Proceda achieved 100% completion rate across all tasks and domains. So every task completes. There are no execution crashes. Now, there were only two domains, abuse referral and KYB know your business, for which I had to use a really large heavy model like Gemini 3.1 Pro. And the reason for that is in these two SOPs, they explicitly ask the agent to exercise subjective judgment. There's language in the SOP that says things like use your experience. So if you have these kinds of open-ended SOPs that are essentially asking you to make judgment calls, you're going to have to bump up to the larger, heavier models to get a higher success rate. Now, I want to make a separate, more in-depth video about the design of Proceda and how that design is actually what enabled it to achieve SOP-Bench SOTA performance with much lighter models. But I'll just quickly mention here that the main idea is that Proceda treats an SOP as a sequence of steps rather than one monolithic document, and it executes an SOP a step at a time, which is very different from what was in the baseline execution in the SOP-Bench paper, where they basically just give the entire SOP and tool descriptions as one giant prompt to the LLM to then reason and execute through. And what that does is it drastically reduces the cognitive and reasoning load on the LLM, because the LLM isn't trying to reason about the entire SOP and all the tools it might need for it in one go. It's only trying to reason about one step at a time. And so this one design decision is what enables Proceda to achieve SOTA performance with much cheaper models. So I'll leave links to all this below, and watch out for the other video that does a deep dive on Proceda's design. Thank you very much.